In figure, A, B, and C are points on OP, OQ, and OC. OR, sorry, respectively, such that AB is parallel to PQ and AC is parallel to PR. Show that BC is parallel to QR. So your job now is to pause, draw your diagrams, write the given, and write what is obvious as part of your proof from the diagrams that you're given, and come to a conclusion. Okay, so pause and try it out now. I hope you guys have done it. Now, first thing is we look at AB being parallel to PR, AB being parallel to PQ, that is. So which triangle should we consider? OAR, OPR, sorry, OPR, OP and R. And next, AC, okay, sorry, I didn't complete the diagram. Oh yeah, by the way, you can see that I've drawn it all together in a weird orientation than what looks over here. That's okay. You know, it's okay to change this orientation. Not a big deal. So you can tilt your page and have a look at the diagram in this way and draw it in the same manner. But don't mix OAP, OAP. Don't mix A and P. You know, OBQ, OBQ. Always verify what you're writing. Because once the diagram is there, you guys have seen that, automatically things will happen, right? Is it not? So it's always good to draw a good diagram. And labeling as well is very important. There's no negotiation over there. So this is O, P, R. Between O and P we have A. Between O and R we have C. Always important to draw a clean and clear diagram. And what is that we have to prove? BC and QR, that they're equal. Well, it's very clear over here. I mean, I'm able to blur this out and just look at this. Just look at that. Forget about whatever is happening around. Right? Like Arjuna did when he shot the eye, or whatever that competition was. Just look at it. Right? We have the triangle, so no need to draw. When you don't need to do the work, it's okay to not to do the work. No, it's being smart is also important. Hard working, it's required, but not all the time. AB is parallel to PQ. AC is parallel to PR. And to prove, we have BC is parallel to QR. Then the proof. Okay. We're starting off with the proof. So in triangle OPR, OPR. Let's write things which is obvious, as AB is parallel to PQ, as for BPT we have OA by AP, OA by AP being equal to OB by BQ, and that's my equation 1. Right, quite simple. Same thing with other triangle. In triangle OPR, as AC is parallel to PR, as per BPT, we can write that OA by AP is equal to OC by CR. That's my equation 2. Now all you have to do is pause and think. From 1 into what is that we can conclude. Is there a negotiator? Yes, there is one. We have the negotiator, and so this will be equal. How does it help? We'll see. OB by BQ is equal to OC by CR. So let's keep it aside. Let's go back to the question. We have to prove that BC and QR, these two are parallel. For that, we need to use what theorem? we need to make use of, to prove that, we need to make use of converse of BPT. And what is converse of BPT ask for? If I prove the ratios, what kind of ratios? OB by BQ. So the ratios are OB by BQ being equal to OC by CR, right? If I prove that, then by converse of BPT, I'm able to prove this to our parallel. So how do you get it? Well, we actually got it now. Job is done. That's it. I mean, I might be sounding like, I'm talking to small kids. Hey, it's there, everything is ready. It is that simple, right? I mean, it's almost like talking to a kid. Everything is quite simple, and before you have to even think about the answer appears over there. So you can see it's not that hard. It's just that, yeah, there are complicated questions. I'm not disagreeing, but this is the way to think. So in triangle OQR, as per equation 3, and I have to go to the next line here. Converse of PPT, we have BC, sorry, being parallel to QR. Hence proved. And my job is done. And your job also is done. So now you can pause and have a look.